We wanted to know how these structures occur, says lead author and CFA astronomer Chengcai Shen, who describes the structures as dark finger-like features. What's driving them, and are they truly tied to magnetic reconnection? Scientists have assumed that SADs are tied to magnetic reconnectio. The process occurs when magnetic fields break, releasing fast-moving and extremely energetic radiation, and then reform. On the Sun, what happens is you have a lot of magnetic fields that are pointing in all different directions. Eventually the magnetic fields are pushed together to the point where they reconfigure and release a lot of energy in the form of a solar flare, says study co-author and CFA astronomer Kathy Reeves. Reeves adds, it's like stretching out a rubber band and snipping it in the middle. It's stressed and stretched thin, so it's going to snap back. Scientists assumed the dark downflows were signs of the broken magnetic fields, snapping back to the Sun after a solar flare eruption. But there was a catch. Most of the downflows observed by scientists are puzzlingly slow, says co-author Bin Chen, an astronomer at the New Jersey Institute of Technology. It's a conflict that requires some other explanation. To find out what was happening, the team analyzed downflow images captured by the Atmospheric Imaging Assembly, AIA, onboard NASA's Solar Dynamics Observatory. Designed and built partially at the CFA and led by the Lockheed Martin Solar Astrophysics Laboratory, the AIA takes images of the Sun every 12 seconds in 7 different wavelengths of light to measure variations in the Sun's atmosphere. They then made 3D simulations of solar flares and compared them to the observations. The results show that most SADs are not generated by magnetic reconnection after all. Instead, they form on their own in the turbulent environment and are the result of two fluids with different densities interacting. Those dark, finger-like voids are actually an absence of plasma. The density is much lower there than the surrounding plasma, Reeves says. The team plans to continue studying SADs and other solar phenomenon using 3D simulations to better understand magnetic reconnection. By understanding the processes that drive solar flares and eruptions from the Sun, they may ultimately help develop tools to forecast space weather and mitigate its impacts. Additional co-authors on the paper are Xiaoyan Xie of the CFA, Siji Yu of the New Jersey Institute of Technology, and Vanessa Polito of the Bay Area Environmental Research Institute. This research was supported by grants from the National Science Foundation. Chengcai Shen, Bin Chen, Catherine K. Reeves, Siji Yu, Vanessa Polito, Xiaoyan Xie. The origin of underdense plasma downflows associated with magnetic reconnection in solar flares. Nature Astronomy, 2022, doi. 10. 1038 per second 41550, 021, 01570, Harvard Smithsonian Center for Astrophysics. 2022, January 27. Scientists explain mysterious finger-like features in solar flares. Science Daily. Retrieved January 27, 2022 from ift.tt/3 UCODISD Harvard Smithsonian Center for Astrophysics. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.